Welcome to the presentation. My name is Ashish Bisht. Today I'm going to cover continuity, slopes, and derivatives. Mathematics gives us powerful tools for understanding the world. The three major concepts are very important to analyze and describe the change around. First being the continuity. It was formally defined by Weierstrass. It ensures the functions behave smoothly. Slopes. It was studied by Fermat. Measures the steepness of lines and curves, essential to understand linear relationships. Derivatives. It was developed by Newton-Leibniz. Measures the rate of change at any point on a function. Plays a major role in fields like physics, economics, and engineering. Let's have a look at the basic concepts. Continuity shows how continuous a function is or whether a function is continuous or not. If the function follows the notation limit x tends to c, fx is equal to fc, the function is assumed to be is known to be continuous at point c. Also, if the values at f of c are equivalent when the c is approached from the right hand side and from the left hand side on the number line. Slope is defined by y2 minus y1 divided by x2 minus x1. Of course, x1, x2, x1, y1 and x2, y2 are the 2 points lying on the line. Derivatives. First derivative is defined by df by dx and also by f dash x. It gives us the rate of change of a curve. Let's go through an example. We can see the basketball falls from the hands at t is equal to 0 under the acceleration due to gravity. Now we can find out the velocity, the displacement, and the acceleration of the ball. And we'll find this going through all these three concepts. We all are aware of equations of motions. V is equal to u plus ct, the first equation. In the free fall case, the acceleration is replaced by acceleration due to gravity. So the equation becomes v is equal to u plus gt. T is the time, u is the initial velocity, and v is the final velocity. Initial velocity is 0 as it is dropped, as we saw in the video. So velocity v of the basketball at any time t is given by v is equal to gt. You can see the graph. In the graph, you can see the slope as well. The slope gives the dv by dt, that is the acceleration, right? So g is the slope in this plot. Time is not negative, time is always positive. So the plot, you see it's only the first quadrant, right? So this is a classic example where you can see the function is really continuous, velocity function is continuous. You can see the slope as well. And you can relate with this diagram, y2 minus y1, x2 minus x1. So if you have 2 points on this, you can get the slope as well. Moving on to the equations of motion 2, s is equal to ut plus half gt square, that is position time relation. We have three graphs here. The first one shows the s is equal to half gt square, where initial velocity is 0 for our basketball case. So it becomes a quadratic. It shows the distance carried by the ball from the initial position. Second plot shows the velocity, which is also the first derivative of ds by dt. The second derivative gives us the acceleration, which is constant, which is g, 9.8 meter per second square. Let's have a look at the real world applications, some of the real world applications. So we all are aware of stock market and finance models. So the continuity helps us generate the functions that ensures better risk assessment and accurate pricing of derivatives in financial markets, which is very relevant these days. Slopes play a major role in structural engineering, road design for safety and ramp accessibility in construction. Below is a diagram which shows the application of slope at different points to generate a digital surface model, which plays an active role in the world of satellite data and remote sensing. Third, derivatives. So derivatives help us understand the maxima and minima of various quantities involved in a relation. For example, in this plot, we have quantity of beers and price of beer. The more quantities you sell, the more profit you make. The more price you increase as a beer, the more profit you make. But it's not true. You have to take the help of derivatives and find the exact point beyond which either you increase the quantity of beers or you increase the price, you are going to incur a loss. So that plays a very important role in commercial industry. The red dot shows the exact point, which is obtained using the first derivative, where it becomes 0 and we find the maximum minimum point. And that's how the researchers in the industry, they define the value of the perfect profit. So that's how these three major concepts play and enhance and modify our life around. I hope you all got some understanding of these concepts from my video. Thank you.